Alright, so now we're going to take a look at an example of a quadratic that doesn't have a leading coefficient of 1 and also doesn't have a GCF that you can pull out. And what I mean by that is if you look at 3x squared, 10x, and negative 8 as three separate terms, there's no like terms that you can pull out of there, right? And to do this, one way we can do this is by using the x method. And the way you're going to use the x method is you're literally just going to set up an x. And what's going to go on the top is going to be the product of your first coefficient, or your leading coefficient, which in this case is 3, and your trailing constant, which is negative 8. And 3 times negative 8 is negative 24. So I'm going to put negative 24 right in the top. And what's going to go on the bottom is our middle coefficient, which in this case is 10. Okay, so now this is kind of starting to reminisce the sum product method that we looked at earlier, because now what we're going to do is we're going to look for two terms that multiply to be negative 24 and add up to be positive 10. And if you did this for a little bit, we can make a table and start listing things out like we did in the previous problem. And if you do that, you should find that you should get 12 and negative 2. 12 plus negative 2 gives you positive 10. 12 times negative 2 gives you negative 24. Okay, so we've completed our x, we have our product, our sum, and our two terms that fit both of these constraints, or that satisfy both of those things. Now, in this case, the next step that we're going to take is we're going to look at our lead coefficient again, which is 3. These two terms that we identified, we're going to divide each of these by our lead coefficient. So instead of 12, we're going to have 12 divided by 3. Instead of negative 2, we're going to have negative 2 divided by 3. And now what we're going to do is we're going to take a look and we're going to see if we can simplify this x. So if I go down here and I'll just make another x, our top is still going to be negative 24. Our bottom is still going to be positive 10. 12 divided by 3 is 4. I'm going to say 4 over 1 in this case. You'll see why in a minute. And negative 2 over 3 is already in simplest form, so I'll just leave that as negative 2 over 3. Okay. Now, to write this as my factored form, same idea. I'm going to start with my two sets of parentheses. And we know that they're going to start with an x. And this is where it's going to be a little bit different. So what I'm going to do is I'm going to look at both of my terms that I have here now. So I have 4 over 1 and negative 2 over 3. Okay? And what we're going to do is the denominator of this term is going to be the coefficient for my first x. My numerator is going to be what goes here. So in this case, my numerator is positive 4. So my first term is 1x plus 4. And now for the other one, my denominator is positive 3. So this is going to be 3x. My numerator is minus 2, or negative 2. So that's my factored form, and I could actually rewrite that if I wanted to, just to simplify it. We know 1x is just x, so this is actually x plus 4, 3x minus 2. And that would be my final factored form for that quadratic.